Dear friends, good evening. I think we can start. Okay. Today we will talk about generative design for 3D printing and about additive design and other aspects of topology and how to create a new form with the maximum performance of these parts. Let's start. Today we will discuss with Anton and Simeon and start. I think we can start. What about the future design and technologies? Um, I think the most inspiring example of new form, new design, and new technology. What kind of company? What do you think about new opportunities for design? What is the famous company in the world which use new forms, new technology,
Uh, SpaceX,
and
yes? No, we go ahead.
okay, yes, I agree with you because SpaceX is a huge company with a commercial special space program which uh, use what kind of opportunities? Additive manufacturing, 3D printing technology, new generative design, topology optimization, and other tools for create a new type of product, yes, for customer. They try to create such performance which meet the requirements of the trends. What about the another company? Yes, the famous company for commercial success in the market. Yes, it's a Tesla, I think. Yes,
Yes,
because so inspiring design and new technology cause the growth of the market opportunities for this company. But I think that when we try to create a new product, a new technology, it's like a mm, black box, for example. Yes, we have some box, yes, and we have only some data about the input parameters. Yes, we don't know the loads, the features inside this box. Yes, and we will try to evaluate the outcomes of our black box. Yes, and it's so difficult to find optimum results, solutions for optimizing what we have inside this black box. Yes, but if you will use some maybe special softwares, yes, maybe we will use some artificial intelligence, yes, new tools for optimizing for um, big data. Yes, for example, we try to find a better solutions, maybe if we don't have in our mind before this process. Okay, and I think we can look the video about generative design.
Over the last 3.5 million years, we've created tools that have in turn helped us create our world. And while those tools have made more and more things possible, they've also defined our aesthetic and limited our imaginations. Until now, if you couldn't draw it, you couldn't fully imagine it. But what if instead of drawing what you already know, you could tell the computer what you want to accomplish? For example, say I want to design a chair. Instead of drawing a chair and then playing with the form, I could instead tell the computer that I wanted a chair that can support this much weight, weigh this much, and cost this much, and produce something based on the material that I've chosen. The computer can then deliver to me thousands, if not millions of design options, all of which meet those criteria. And from those options, I can pick the one design that delivers on the most important criteria. And the one that I select might not even been one that I could have imagined on my own. That's the promise of generative design. But why is it important? It's an entirely new way of doing things, and the benefits are potentially staggering. Unprecedented reductions in costs, development time, material consumption. The sky's the limit. And when we combine generative design with the emergence of new forms of manufacturing like 3D printing, we suddenly have access. Traditional manufacturing methods require you to make massive numbers of something just in order to be profitable. Small designers without access to production resources were simply out of luck. But now we can do a batch run of just one. The stage is being set for the reemergence of local manufacturing. Generative design extends beyond manufacturing. In fact, everything that's designed will be affected, including the built environment. How do you create an ideal floor plan? Can we balance structures for material type, strength, and energy consumption? Generative design promises a way to answer these questions and to create designs that avoid waste and control cost. So all that's great. What does this mean for the designer? Now they will co-create with the technology, choosing the constraints and setting the goals. The software simply determines the most optimized way of achieving those goals. It's going to lead to astounding results. And that's generative design.
Okay, and I think we should answer these questions. Yes, why? Why we need to use new types of product to create new shapes, new design? Yes, why we need to find a new way of our future? Yes, uh, we should like to find the balance between the performance and the cost of product. Yes, because our economical situation is so hard to some local manufacturing. That's why we need to involve this aspect as a cost. Yes, a cost efficiency for design process. Because if you would like to change some initial and original design part, yes, we need to answer for these questions. Why we need change this form? If it's for mass production, yes, we don't need this form because, for my opinion, yes, I
Yeah,
think when we try to something change, we need to increase the cost because we spend more time and more investment in this process for changing. Yes, and try to produce a prototype, maybe, yes, maybe some samples for tests. That's why we need to find a balance between the performance of our product, yes, for example, for individual application, for customization, yes, and the cost of this product, because we try to find our area of market, yes, and sell more of this new product. What about how? How we can to change our design, our product, our 3D models? We need to use more softwares, yes, and we need more power for this. Okay, it's deal with some algorithms, some mathematical model, yes, some numeric model. We need to try any tools for optimizing. What we would like to change, what we need to use, how, not how, what? Yes. What about the manufacturing technology we need to implement in order to make this new product, new form, new design? Yes, because the task of generative design is to consider about the manufacturability of our products. Because today we have many types of production technologies: casting, CNC machining, 3D printing, and inside 3D printing we have many types of technologies: FDM, SLM, SLR, and other methods for production. That's why if we try to change something, we need to think about why, how, what I need to change in order to meet the requirements of our customer or market demand. What about their traditional development process? Yes, uh, for traditional design, I have some uh, concept or idea. Yes, I think about what? I think about the form of my product. Okay, I have some goal for production, for example, to meet the requirement of aerospace, for example, yes, and I have some constraints of manufacturing and my, for example, softwares for design for modeling. Okay, I try to evaluate some, make the first design, the second design. It's some iterations, yes, and I spend too much time for try these variants of design in order to find the optimum. But I don't know what kind of this design is optimum before manufacturing this part and test them performance. Yes, that's why I have not too much variants. Yes, I have a few design forms. Yes, in order to create and manufacture. But unfortunately, we have some uh, defaults in the manufacturing process because we chosen not very manufacturability materials, for example. Yes, maybe we did not use appropriate tools and equipment for this process of manufacturing. Yes, that's why we don't get a good product, a good design. Yes, and we okay. And for me, I think generative design is useful tool to discover maybe unexpected and even better performance of our product. Yes, because it's a black box. Yes, we don't know what inside this box, what inside this evaluating and simulating in design process. Yes, we have task, we have many constraints and limits, yes, and we need to get the set of outcomes. I think it's maybe some surprises after simulation, yes, when we get a better performance product. And we can consider the wide range of aims, goals, objectives, yes, to find advanced design solutions. Next, I think. Okay. When we need to use this type of design. Yes, when we try to find alternative, yes, for future, for new task, or if we try to use new techniques for manufacturing and for new applications, for example, yes, if we need to check our idea. For example, if we try to redesign some aggregates, yes, and we have original design, initial design of these aggregates, yes, and we try to use these aggregates to another applications, for example, yes, we can use this type of design, generative design, yes. It's a new product development, yes,
Yes.
create a new product, maybe a new features of this product and new applications, a new. If we try to create new, we use generative design.
Yes.
What about the reduced raw material? It's the same, I think, topology optimization, yes, but the topology optimization, for my opinion, is a part of generative design. What do you think about this concept?
Yes, I
Agree.
agree.
Okay. And what about the some increasing or reduce the weight, maybe try to increase some durability, some features for life cycle of our product. Yes, I think it's the same, a new design, a new applications, implementations, and new features and new performance. Yes, and maybe some new outcomes. Yes, and I think if why we didn't use this design before, because we don't have a 3D printing technology,
Yes.
additive manufacturing. Yes, uh, when we start used this technology, 3D printing and additive manufacturing, we can create free form. That's why we can create some generative design parts. I think it's changing the paradigm of
Paradigm.
uh, design development. Yes, because we have some limits from manufacturing, yes, but today we don't have these limits. We have an open space of manufacturing technology because layer by layer method, yes, help us to create a free form such as generative design forms, I think. Okay, next slide. When to use generative design? Everywhere where you try to use something new, maybe for comfortable for uh, using, comfortable for visualize something, yes, for touch, for bring, yes, if we deal with some lightweight constructions. I think you can change some subjects and products and goods in customer product and buy them. Mhm. This is an example of generative design implementation in automobile. Yes, we redesign uh, wheel. Yes, and create a new form more comfortable for utilizer. And what about the price? Yes, the main task and limits for manufacturing process. We should find a balance between cost of product and
And
performance.
performance, yes.
Yes. What about the cost? Cost include material cost, process cost, labor, and other overhead which we have in our production system. What about the performance? It's our output parameters, yes, some efficiency, and the cost of life cycle of our new product, yes. That's why we need to find a balance, a compromise of these two target and limits constraints, yes. It's something, I think it's some the formula, yes, of depending their performance from cost and cost from performance, yes,
Mhm.
because if we um, include in our manufacturing process less money, yes. For example, we don't use modern and advanced material, yes, so we use less engineers and researchers, yes, we couldn't get better performance. That's why if we try to get better performance, we need to involve better material, better process, advanced process, yes, advanced material, and maybe scientists, okay, and engineers. Okay, and you see some
Examples.
curve about the price of performance. Yes, it's some uh, dependencies between the design, the performance, yes, and the price of this product. If I have, if I'm not rich man, girl, woman, I pay only for first car. Yes, if I have a good job, have a good salary, I can buy medium car. Yes, but if I'm such engineer, best engineer, and excellent
And
researcher
additive
in
technologies.
additive technologies, yes, I can buy so rich and high performance car. It's our future. Yes, and it's good that I can create this better performance product and we can produce them. Yes, I think
Yes.
it's our future, best future. What about the
Example, Kronstein
brackets?
brackets.
Yes, you see the different variants, types, and modification of this product in this slide, yes, and you try to find a better solutions for your implementations, yes, applications. And if you remember, last time I told about customization product, customized product, yes, and mass production. This is the same situation. If you try to produce many products and don't change the shapes, don't increase the performance and the features of our product. You can spend less money and get less cost for customer. Yes, but if you try to create some innovative design, yes, and realize some new concept of designing, you have a more cost, more high cost for production. I think it's clear, and it's the normal situation in manufacturing companies. What kind of manufacturing technology we have in our industries, in such industries? Yes,
Mm-hmm.
in such industries, aerospace, automobile, medicine, yes, some
Jet
engineering,
engines.
yes, for jet engine productions. It's the first place for additive manufacturing, yes, because we can
This
produce
future
some
of
raw
manufacturing.
materials, yes.
Yes.
We have some casting for high precision parts, yes, when we have the form and perform castings. uh, we have some CNC milling and toning, yes. And today we use this type of technology for post-processing after additive manufacturing process. And we have some heat treatment in order to increase the performance after printing for such materials, for such material as titanium and Inconel, for example, yes, because we need to increase the mechanical characteristics of these manufactured parts.
What if you could come up with thousands of options for a single design without drawing, all of which meet specific goals set by the designer? And from those options, pick the one design that delivers on the most important criteria, the design you couldn't possibly have imagined. This is generative design, a technology that harnesses massive computing power, creating forms with precise amounts of material only where needed, achieving maximum performance while wasting nothing. But generative design can be about much more than simply turning out alternatives. Prototypes can be scanned and equipped with sensors that provide real-time performance data that can be looped back into the design process, so the object, in effect, co-designs itself. And depending on the material and method of manufacture chosen, the software can optimize the design for those choices. In its search for the optimal design, generative design creates complex forms that would otherwise be impossible to make using traditional manufacturing methods. Now, with advancements in material science and the ability of 3D printers to print metal, companies like Airbus can create forms like this airplane partition panel that's half as light and just as strong. The result? Significant reduction in fuel costs and CO2 emissions. The things that have limited us in the past, software, materials, manufacturing, no longer do so. With generative design, the world can look and perform any way we want it to. This is the next stage in the evolution of design, and it's happening now.
Okay.
Mhm. And what about the workflow of generative design? Yes, uh, first of all, we try to define the goal, the aim, the targets of our project, of our design changing, design optimization. Yes, and define some constraints for our process of optimizing. Yes, we try to create the CAD model, CAD file of our product, yes, and we have some set of geometries. Yes, it's a product at geometries. We generate some design. Yes, we can define these standard and unstandard parts for assembly, for designing. Yes, uh, then we generate. Yes, when we for example opens the software such as Fusion, yes, and try to find the best variants for our goals. Yes. uh, Maybe if when we will find these solutions, we can analyze the working process, maybe some features of this product, of this design. Yes, for this design. uh, I think we can perform some iterations, because for beginner, yes, it's not very clear what kind of um, variant of kind of items, yes, we can use for this purpose, for this goal. For me, it was difficult from first step to find a better solutions. Yes, but if we will use specific softwares and maybe some mathematical modeling and algorithm, yes, it will be more easy and quickly. What about the analysis? Yes, we analyze some stress, some mechanical properties, yes, and try to find better solutions for our goals. And we think about manufacturing technology. If we use 3D printing, yes, and I think you remember about what it means, uh, additive design. Yes, I hope you remember. It's part position, part location on the building platform or substrate of 3D printer. Yes, it's adding some support materials in order to uh, support the overhang surface of our product. Yes, it's the set of technological parameters for printing. Yes, which is connect with our material, the properties of our material. Yes, it's very important for generative design uh, to consider, to think about material and manufacturing technology in order to make and produce excellent, exciting, yes, um, product design with this optimizing, with this changing. I think we will continue with Simeon, yes, and he uh, will talk about Autodesk Fusion
Demo.
software, yes, 360 demo version, and you can try uh, this program for generative design. Please, Simeon, let's start.
Okay, let's continue with some dive into software. Just a minute, I want to demonstrate my screen. Okay. I think it works.
Yes, we see your screen.
Okay. I want to describe some design process that I have experienced with my friends at a local startup for this Mediterranean bike with tracks with one ski. Has some body from aluminum, and we try to do something new, try to explore new bodies, and try to new designs. Maybe for startups like this, it's too expensive to produce some details after or with generative design, but it just some materials we try to understand, try to produce, and try to explore because it's startup. And we have some software like Fusion and trying uh, trying it. Um, Here we start with some CAD model. It's just a simple model for vehicle. Oh, of course, it's electric vehicle. it has some batteries and electric motor inside this truck. So afterward, we go to Generative Design and try to describe our task. It's about today. It's not about some parameters, because it just for seeking some ideas. It's not about mass, maybe it's not about cost, and not about the manufacturing method, but we starting from preserved geometry. It's geometry that will be the joints for our future design, and obstacle geometry. It geometry for some objects where we don't want to generate or maybe design or maybe construct some part. Afterward, we have some objective. Of course, it's mass, maybe some limits for safety factor and etc. And of course, manufacturing. I tried different for just this case. Of course, we have loads, forces, and gravity, as you see as blue points. So afterward, when we described these parameters, we just generate the models and trying to explore something with tables maybe, or plots and something like that. Of course, we can use some steps between starting points and end points. It looks like iteration from artificial intelligence and some steps how our design were developed, and try to understand which parameters have been changed, and try to seek ours. For example, we have multiple designs for different technology and different materials, and it's interesting when you can change or you can change some parameters, and then you have some different design. So we ended with some geometry like this. One moment. It is a CAD ready object which we can produce with 3D printing, and of course we can change some parameters or the entire models for our needs, and it's so easy to produce something custom, something what you need, and it's look like maybe from future, and it's not only the result from it's just one result. We have many results from this process, and just trying it with potential clients, with startups, investors, and so on. So we just produce new design and it's how looks the entire process as small introduction, I think. Yes, I think it's all what I can to show in this time. So I can give word back to my colleagues, I think.
Sorry, please, can you whenever I want to download this the 3D Fusion, the Autodesk Fusion, we need to download the AutoCAD 360, right?
Yes, yes. One one main idea that you can try it. It's you need educational email like at Edu or maybe from university or something like that, because educational license give you generative design. In other versions, they are not generative design. Just just try it with educational mail.
Okay, education MBA. Okay, thank you.
It's not too hard. Just go to Autodesk site, just log in, just register with this mail, and Fusion 360 is free for students. And generative design in educational use, of course, is free for students. Just try. No any problems with it. I'll try to search this maybe. Okay, it's has different licenses, but only one software. Just you need this email and educational license Fusion. You can use it. Yes. Maybe any questions I can answer. Okay, so where is my colleagues?
We're here.
Okay, so let's you continue if you want, or something, maybe questions from our auditor.
Yes, dear guys and friends, I send in common chat some links to AutoCAD examples how to perform this generative design. Yes, and you will get the example and some guide tutorial for realize your task for this international school. Yes, you will get, or you got yet, yes, yet got 3D model. I don't remember the name of this part and design, and you have two videos. It's video instructions how to create the new design and realize generative design. I think it's will be easy for you, yes. And if you will have some problems, you can write in chat or by email, yes. And I think Simon and Anton helped me to answer for these questions. I send another links for different examples of these activities, how to perform this generative design. And if you are interested in these activities of our international school, yes, I think you will continue um, this experience.
Ну, еще, кажется, надо сказать, что не только вид программного обеспечения, есть много таких программных
And
обеспечений.
we don't promote only Autodesk softwares, of course, yes. We can use another softwares for such purpose, but for free license for student for educational purpose is the best way for try your skills on the modeling. How we can use 3D printing in aviation? In aviation, yes. Um, how we can use
For
in
aviation,
different ways. For aviation, we can create such design for airplane, for example, yes, from aluminum or titanium, yes, for airplane, and printed it in the different way in SLM, electron beam melting technology. I think SLM is the best way for higher performance and precision part.
Но тут надо сказать, что аддитивные технологии появились аж в
Я уже об этом
1986
говорила в
году.
прошлом году,
Да?
в прошлый раз.
Окей.
And
Ну, можно сказать про
for,
горелки и General Electric.
for example, the most famous example of 3D printing application in aviation is the LEAP nozzle for combustion chamber, yes, which consists of 16 separate parts, but using 3D technology and optimization such as topology optimization, General Electric created a new nozzle, one single nozzle, yes, without assembly, and improve the fuel consumption during the
Порядка 15 тысяч уже
aviation.
сделали.
And these leaps, these products are in some medium series of manufacturing. What part of airplane we can print it? I think engines, of course, yes. And maybe some external parts inside the airplane.
Ко мне вопрос?
At last study, we will discuss the different areas and industries for which we can use 3D printing. Of course, it will be aviation, aerospace, open space maybe. I think yes, because we will involve the guys from another international school for this study. And for aviation is the best way for implement generative design because we can reduce the weight, yes, and improve the performance of total product. Total product is airplane, yes.
Yes, of course.
And maybe make some product or parts more ecological. For example, if we produce some elements such as CO and NO.
Okay. Any
Questions, please? I think you can start download these softwares, yes, get your license file and start practice because you have too much links for if you don't want to try to create some parts, you please only look these videos, yes, and you have the tutorial of Autodesk Fusion 360.
Yes.
Thank you for your attention and you come in this class. Tomorrow we'll discuss some practice in which field?
Additive manufacturing.
Additive manufacturing softwares for simulation the process of melting and how to make some
displacement,
part correction
да,
during
part
before printing in order to eliminate some form deviation, some heat stress during this process. It will be more physical practice. If you don't have some questions, I think you can continue with practice with generative design and try softwares, look videos, yes, and ask by chat, write in chat and
Yes.
by mail, yes, of course. Thank you, and please start your practice. Okay, I think we can come back in our lab. Yes, and thank you, Simon, for your practice masterclass.
Thank you.
Thank you very much. And please, guys, start your practice and look videos, and you can write for us in a chat or by email. Okay.
Goodbye.
Bye. Thank you.